Hello, everyone. I decided to make a series of videos about password cracking. So let's start with brute force attack. So first, let's take a look at the setting for password cracking. So this is the basic setting. Suppose the username and the hash of user's password are stored in a password file stored in the system. And by some chance, the attacker has access to this password file. And then for the attacker can read all the entries of the password file. For example, like if one entry is like, okay, the username is a Trunley and the password is this. The hash of the password is this. And this hash could be MD5 or could be SHA-1 or could be more advanced hash functions. So in the example of a brute force attack, let's choose, suppose I have made a pretty weak password with only 4 letters in lowercase. So I have password equals, let's say, yard. And then I use the hash function as MD5. Then we have the MD5 of the password equals some string. It is 100-bit. Normally it is given in hexadecimal form, and it's 30 bytes in hexadecimal form, because each character is counted as a byte. In hexadecimal form. Okay, now let's change to the terminal. So in this terminal for brute force attack, we have 2 types of brute force attack. One is using lookup table. The other one is not using lookup table. So let's start with the one without lookup table. So basically the attacker just calculate MD5s with different possible inputs until the attacker finds the correct input for the target hash. For this reason, then let's first test the speed of MD5 to have some estimation. I have prepared some code for testing speed. Like this. It's a very short code just to test the MD5 calculation for 1,000 times. We use this command in terminal time, and we can run this bash script, 1,000 MD5. Okay, in my laptop, it runs 1,000 MD5 in 2 seconds, like less than 3 seconds. So it means that my laptop can run MD5, individual MD5 hash, like around 350 per second. And then if we have some estimation for this four letter in lowercase, and we have 20 to the power 4. These are all the possible inputs in the worst case, and we can calculate around 355 high MD5 in our laptop. So it's around 1,300 seconds for all the possible four lowercase letters as a password. Now, since we have chosen yard as the password, and we can calculate the MD5 next yard, and we have MD5 sum. This gives us, I can use MD5. This gives us the MD5 of yard. Here in macOS, they don't have MD5 sum. In Linux, it's obsolete. So Linux has a built-in MD5 sum, but it does not have MD5. Okay, so to brute force this hash, and then I have this file. It's a bash script again. It's very simple. So this is a target hash as argument for this this command, and then I have these 3 fields: x1, x2, x3, and they combined together gives a 4-letter in lowercase, 4-letter inputs. And I tried to calculate it, and if I found this target hash, I will. If I found this target hash, I will output with this username. So in this case, the username is myself. Okay, so let's run it. And we have brute force. This is a target hash provided as the argument for this command. Oops. Some error here. The reason is in the code, I wrote it in the Linux environment, so I need to change it a bit. I need to replace MD5 sum in the Linux environment to MD5 in macOS environment. And we can run this command again. So to make sure the program is still running, so I print out some dots. Each dot means it runs this 26 times 26 possible input. So we can leave it here, and we will come back soon to see when how long it takes. Welcome back, everyone. So now this command has returned the result. Where you see it's yard, and then this is the hash. It's the same as this hash. And in my laptop, it took nearly 19 minutes to recover this password. Although it seems a very weak password, only 3 lowercase letters. As we have guessed out, like for previous the calculation of the time, and it's in the worst case, we have 26 to the power 4 divided by 355. If we further divide by 60. So in the worst case, it would take around 21 minutes to exhaust all the possible input. So then natural question is, if we have 5 letters, then what's the expected time in the worst case? Now we can change here from 4 to 5. Okay, it's around 560 minutes. It means that if we use this pure plain brute force attack method, if we want to recover a 5-letter password for MD5, then it would take 9 hours in the worst case. So can we speed up the brute force attack? Since it's just for demo for only with 5 letters in lowercase, the attacking time seems not very promising, right? Let's look at another approach. It is brute force attack with the lookup table. So in this folder, I have generated this lookup table for the text, like for the possible input with lowercase letters up to 5 lowercase letters. So if I print some of the result, it's like this. So it stores the hash MD5 hash of this letter. And you see it starts from AA, then AAA, and starts from B and C and D and so on and so forth. This is some content of this lookup table. It's just the hash of the password and the corresponding password. So if we are given a text hash, which is a hash of some password of up to 5 lowercase letters, then we can use this table. We read this file line by line and compare the hash against the typed hash. If it matches, then we have the result. This is the idea of using the lookup table for brute force attack. In this case, let's try another password. Let's see cyber. Okay, it's a 5 lowercase letters until MD5. So we have this hash of the cyber, the input. And then we can use true, false, 1. We want to know the total time for this process. So I add this command time to test how long it takes. So let's start. Yeah, once again, some error. The reason is I have changed the name of the lookup table. Here, I use this name, but it should be lookup Md5. Is this correct? Lookup Md5, it's correct. No, let's try. Okay, now it starts running, and we will be back after it gives us results. Oh, welcome back. So it took less than 1 minute, 37 seconds to find this this password for this touched hash. So it's pretty efficient. So maybe we can try another one since it seems it's quite fast. Let's try security, but we cannot, not secure, but we can only have 5 lowercase letters here. And then we copy this. We replace the hash with the new hash. Let's see how long it takes. Welcome back. So now we have the result. It found the corresponding hash and the touched hash and the corresponding password here. So it took less than 4 minutes. So now you see the speed up of using looking up table than brute force without looking up table. Okay, so then it seems pretty handy. We can use lookup table to conduct a brute force attack. Well, let's do some calculations. And for MD5, like it is 128-bit output, since the output is in hexadecimal form, and each of them, it means 1 byte is given in 2 letters or 2 characters in this form. So it means that for the output of MD5 in hexadecimal form, it requires 32 bytes to store the output. And together with the possible bytes of the password, and for 5 lowercase letter, then we can consider that's 5 lowercase letter together with this column, then it's 6 letters. 6 letters together with this 32 bytes. So it means that each possible password in the lookup table will occupy around 36 bytes. Then we have 26 to the power 5. And times 36 bytes. This is the storage cost for looking at table. And we have kilobytes and megabytes. So it's around 420 megabytes. Well, in fact, let's look at this lookup table. Here, it contains all the possible password with lowercase letter up to 5. So it contains 1 lowercase letter, 2 lowercase letters. In this case, it has more, but we have kilobytes, megabytes, so 481 megabytes to store all the possible password and MD5 hash in this table. Well, in most of cases, we use a stronger password instead of just 5 lowercase letters as our password. And we have a longer password. We use some different characters, different symbols in our keyboard. So for English keyboard, we have 97 possible keys. And if we use, let's say, 6 as the length of the password, in this case, suppose we again use MD5 to store the password. And at times 36, and I to count it to easily count it. So we have okay, and it's megabytes. So kilobytes and megabytes, gigabytes. Okay, we have to use around 29 terabytes to store all the possible password and its corresponding MD5. And if we use SHA-512, in this case, and we have 512 bits. That's four times of the 128 bit. If we use SHA-512, it means that we have 32 times 4 plus this 6 or 7 characters. For this is the number of bytes used to store the possible password and the hash for the password with SHA-512. In this case, let's see. Okay, terabytes and more than 100 terabytes. So for individuals, it's pretty costly. Notice that here, we have been pretty conservative. We only set the password with possible length 6. But in most of cases, we would choose a password longer than 6, let's say 8. In this case, we have, okay, this terabytes. And then I don't know the English word for this number for storage cost. So then it seems we cannot use looking up table to speed up the brute force attack if the user choose long password or good password. And that's all. Yeah, we are in good shape now. But there are many smart attackers and researchers. So some researchers come up with the idea for rainbow table, which can get good trade-off between the time cost and the memory cost. So this will be covered in our second video for rainbow table attack.